In Chapter 9, we will talk about physical properties of solutions. We were talking about solids and liquids, and we just finished the chapter on gases. But Chapter 9 now we will focus on solutions. And here are the topics that we're going to cover. So we will start by introducing general properties of solutions. Solution, as we mentioned in a previous chapter, is a word that is applied for a homogeneous mixture. When we have a solution, we have a homogeneous mixture. It's a given. What does it mean that we have a homogeneous mixture? Just to review a little bit, remember that the components in a homogeneous mixture are really mixed very well down to the molecular level, and we cannot tell the components apart. Think of salt water or sugar water. We cannot tell which one is the sugar molecule and which one is the water molecule. To have a solution, we have to have at least two components. We cannot have a solution with just one component. And here are the terms that we are going to use when describing a solution. A solvent and a solute. A solvent is typically that substance that is in the largest amount, so it's present in the highest amount. The solute, we can have multiple solutes, but at least one of them is dissolved, the dissolved substance, and it's in a smaller amount than your solvent. So the solute gets dissolved in a solvent, and the two of them, solute plus solvent, form the solution. Now we can have, as we said, multiple solutes, but we have to have at least these two components to make a solution. We can have different types of solutions. We can have solutions in the gaseous phase, in the liquid phase, in the solid phase. So when we think of solutions, we think of the liquid phase, especially aqueous solutions that are formed from water being the solvent, but that's not always the case. Air, for example, is a gaseous solution. It is formed by all different types of gases, and actually the highest, so the solvent in air is nitrogen, and then we can have many solutes. Water vapor, we can have oxygen, we can have argon, hydrogen, helium, so there's many solutes in air. We can have a liquid solvent and a gaseous solute, and the solution is liquid. We can have carbonated water, carbon dioxide dissolved in water. We can drink carbonated water. Okay. We can have liquid solution where the solvent and solute are both liquid, right? Hydrogen peroxide dissolved in water. We can have a solution, liquid solution, where we have a liquid solvent and a solid solute. Salt water. I take salt is in solid form, and I dissolve it in water, which is liquid, gives me a liquid solution. And then we move on to solid solutions. We can have solid solvent and liquid solute. Mercury and silver, used in dental fillings a lot. We can also have solid solutions where both solvent and solute are solids. Common brass, it's zinc dissolved in copper. Right? So the brass instruments that kids play in bands, they're zinc dissolved in copper. When we talk about solutions, these are terms that we're going to use as well. We can have a saturated solution, an unsaturated solution, and a supersaturated solution. We'll start with unsaturated solution because it's the easiest. This is a solution that contains less solute than it has the capacity to dissolve. So I can keep adding more solute, dissolving more solute to an unsaturated solution, because it hasn't reached the limit of the highest capacity that it can dissolve of that solute. A saturated solution, on the other hand, is, and we're going to talk mostly about aqueous solutions, solutions with water being the solvent, but those saturated solutions are those solutions that contain the maximum amount of solute that will dissolve in a specific amount of water at a specific temperature. Now, I could vary the amount of water and I could vary the temperature, and that will change the amount of solute that I can add. But for a specific amount of water, so if I don't change the amount of water and I don't change the temperature, I only have a maximum amount of salt or sugar or whatever the solute is that I can dissolve. And that is called a saturated solution. Just intuitively, we know what saturated means. The amount of the solute that is dissolved in this saturated solution is called the solubility of that solute in water, typically, because we're talking about aqueous solutions. A supersaturated solution is one that contains more solute than a saturated solution. We can obtain this not by varying the amount of water, but by increasing the temperature. So if I increase the temperature, I can actually add more solute that can be dissolved in a solution, in a certain amount of solvent for a solution, and I can create a supersaturated solution where I have more than I should, more solute than I should have for that particular amount of solvent, and it can only happen because I'm increasing the temperature. Now here's what happens when I have supersaturation, right? So if I dissolve this which is a lot, this amount of solute into my solvent, and I increase the temperature, make sure that it actually does all of it dissolves. Now what happens is if I lower the temperature back to where it was, and I introduce what is called a seed, an impurity into this beaker that is containing the supersaturated solution. What happens is when that gets dropped in, all of the extra amount of the solute that I was able to dissolve is going to completely fall out of solution, forming this big crystal, so crystallizing immediately. It just needs that little starting point that I provide, and then all of it just falls out of solution. Because it's supersaturated, it has more, for a certain amount of solute, it has more, or solvent, I'm sorry. For a certain amount of solvent, it has more solute than it should have. And I do that by changing the temperature. But once I cool it off, right? And I introduce an impurity in there, a seed where it can actually trigger that crystallization, it will all crystallize very quickly. You can watch these on YouTube, or you can even do it yourself. Just take a container and dissolve extra salt by warming it up and then letting it cool slowly. Make sure you don't touch it or bump it, and then add a little bit of extra salt in it once it cools off, and you will see how quickly you will get these crystals falling out of solution.